Hello everyone. So now I'm going to show you how to conduct a one sample hypothesis test, a one sample t-test. So here's an example. A psychobiologist hypothesizes that the diastolic blood pressure of type A males differs from the average male. In the population, the mean diastolic blood pressure for males is mu equal to 80. The psychobiologist takes the blood pressure of N equal to 25 type A men whose ages range from 21 to 29 years. The sample mean diastolic pressure is M equal to 93, with a standard deviation of S equal to 18.76. Do the data indicate that the diastolic blood pressure of type A males differ from the average male? Conduct the appropriate hypothesis test using alpha equal to 0.05 and state your conclusion in terms of this problem. Make sure to use APA-style conclusions. So our first step, well, before we get to the first step, notice that I highlighted all of the essential information that we're going to need to pull out of this particular problem. Okay? So step one is to state the hypotheses. So the null hypothesis is that mu is equal to 80. The diastolic blood pressure of type A males is not different from the average male. The alternative hypothesis is mu not equal to 80. The diastolic blood pressure of type A males is different from the average male. How do I know that this is different and this is not a one-tailed test? Right? We don't know the direction because of the question that is being asked right here. Do the data indicate that the diastolic blood pressure of type A males differs from the average male? This is not asking us lower, higher. We have no idea, right? So this is not equal to. Okay? Step two. Set the criteria, locate the critical region, right? So alpha was given to us is equal to 0.05. It's a two-tailed test because the alternative is no different. There is a difference, not equal to, right? So it's a two-tailed test. We don't know the direction. Degrees of freedom is n minus 1, so n is equal to 25 minus 1, so degrees of freedom is equal to 24. The t-critical value for a degrees of freedom of 24, two-tailed alpha 0.05 is equal to plus or minus 2.065. So let me pull up the t-table and I'll show you how I got that. All right, so here is the t-table that is posted on Canvas that you can actually use. And so what you'll notice is here are the proportion in one tail, right? So alpha 0.25, 0.1, 0.05, 0.025, 0.01, and 0.005, and this is in the one tail, right? And that'll correspond to these columns, right? The proportion in two tails, which is what we're actually looking for, right? And alpha is 0.05. We're going to be looking in this column right in here, and we're going to look for the row that says 24. So here is the row that says 24, right? So there's 24. So we're going to move over, and the t-critical value, right, that corresponds to alpha 0.05 for a two-tailed test with degrees of freedom of 24 is going to be plus or minus 2.064. So the t-critical value is the value that we are going to try to beat with our test statistic, with our calculated t. So this brings us to step 3. Now we're going to go ahead and calculate our test statistic. So I've gone ahead and rewrote what our values are, right? So mu is equal to 80, m is equal to 93, s is equal to 18.76, and n is equal to 25, right? So this is our population mean, this is our sample mean, this is our sample standard deviation, and this is our sample size, right? Now, we're doing a one sample t-test, so our formula is t equal to sample mean minus population mean divided by the estimated standard error, right? And estimated standard error is equal to sample standard deviation divided by the square root of n, all right? So I always start with estimated standard error. I always start with getting rid of the fractions in the denominator because it's just easier to calculate. So plugging in the values, I get 18.76 divided by the square root of 25, which gives me 18.76 divided by 5, which is equal to 3.752. We're now ready to plug in the numbers into the t-test. Right? Our calculated t is going to be 93 minus 80 divided by 3.752, which is equal to 13 divided by 3.752, which gives us a calculated t of 3.4648. Now, when you look at this calculated t, the question is, did we beat our critical value of 2.064? So this brings us to step 4, right? We take the obtained t statistic, which is 3.46, I rounded up to 2 decimal places, which is greater than the t critical value equal to 2.064. So our decision is to reject the null hypothesis, right? Our calculated t beat our critical value t. So we reject the null. So since we reject the null, we need to calculate an effect size. We need to provide a measure of just how different is this calculated t, right? Or just how different is this sample mean from the population mean, right? So I went ahead and did an estimated Cohen's d. You could do an r squared if you want, but you have to pick one. You can't do both, so you have to either do an estimated Cohen's d or an r squared. So I picked the estimated Cohen's d, which is sample mean minus population mean divided by the standard deviation. So it's 93 minus 80 divided by 18.76. 13 divided by 18.76 is equal to 0.6929, right? The 95% confidence interval is sample mean plus or minus the margin of error, which is our t critical value times estimated standard error. So 93 plus or minus 2.064 times 3.752 is equal to 93 plus or minus 7.74, which gives us a confidence interval, or 95% confidence interval, of 85.26 to 100.74. So this brings us to the last part, is to state the conclusion in terms of the problem, right? So here's our conclusion. So we reject the null. There is sufficient evidence to conclude that the diastolic blood pressure for type A males is significantly different than average males, comma, and here's where we need to make sure that we provide the statistics to back up the claim we just made, right? So, comma, t, parentheses, degrees of freedom, 24, equal to 3.46, comma, p less than 0.05, comma, estimated d equal to 0.69, comma, medium effect, comma, 95% confidence interval, bracket 85.26, comma 100.74, close bracket, period. Type A males have higher diastolic blood pressure than average males. So I always recommend to add the second sentence to kind of put this in English. So what does it mean? What does the conclusion actually mean in English? So there you go. There's an example of a one sample hypothesis test.